All right, so for your homework, because we didn't talk about this yet, Sophia, by the way, feel better. Okay, if you just want to do all of them, you can.
No. Yeah.
I mean, unless you want to talk about it.
Yeah, but like, I thought you mean we didn't talk about any of them. Their husband smiled, so you was like, I can do whatever you want.
So there's a lot of homework questions here, right? I don't need you to do all of those, but I would like you to complete the problems that you need to work on. So that's up to you. Instead of me saying do this, 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 and this, if you still need to work on factoring quadratics, choose one of those. If you still need to work on two-way frequency tables or area models, or like choose the problems that you feel like you need practice on. Okay? Same deal, Sophia. Choose whatever you think you need to work on. We need a okay. Secret code word will happen later in the video, Sophia.
Do we get ice cream sandwiches?
I don't know. I'm out of ice cream sandwiches right now, but I gotta go to the grocery this weekend anyways.
We get something.
All right, so if we come here, if we did across the top exercise and not exercise, and then fruits and vegetables. So we have they do exercise or they no exercise. And then what's the other thing?
Fruit and vegetables. 5 servings of fruit and vegetables a day.
Fruit plus B. No fruit veg.
You will sadly probably encounter some people when you go to college that do not eat any fruits or vegetables in their diet. That's really unhealthy. Like, your body can survive on that, but it's really unhealthy. Like, currently I am trying to stop drinking soda, like pop, because it's really unhealthy for you, and incorporate more fruits and vegetables. So, I do exercise, but if I don't eat any fruits and vegetables, versus if I do exercise and do eat fruits and vegetables, obviously this is the healthiest option, right? We exercise and we eat fruits and vegetables. What? I got you guys, because you can't pull it shut from over there. You'll hit the bookshelves. I got you.
I bet his one arm is really strong.
So, what goes where? Help me out.
Is this an eruption? Could I please have Teak and Raleigh Slack to the office, the remote office?
So you said 57 goes in here?
That's like more than half, so I mean.
And then the 100% on the bottom right corner.
And then the bottom right, way out here, is 100% or 1.
And then exercise.
Like 35% they exercise. It would be like across from where it says X. Would be 35.
Across?
Yeah. I mean, up exercise.
Down. Okay, so at the bottom of the column for exercise, we have 35%. So that's 35%, and we're going to add some percent here and equal 100.
65.
This would have to be 65%.
That would have to be 8, which means, well, we know that that thing is 33 because it told us that.
Across from fruits and vegetables.
So we know that it's 25 for exercising.
And that's 67.
And then 25 in both.
25 and 10. Not both.
25 in
No, I mean
both,
both.
like both.
Oh.
So, when we talk about these probabilities then, the probability that they exercise and eat fruit, that's the and, right? So 25%. Our table tells us that, but we could compute it on our own. What do we do with an and probability situation to compute the and? This is tricky because and in math normally means add.
Wait, you mean and or?
And. So if we're talking about B, and if we talk about, like, if we didn't have the table, I'm just trying to review. How do we compute an and probability situation? We don't add. You multiply. So you would take the probability. So part of this lesson is reviewing some rules. So the probability of A and B, and you can write out the word and if you want, but I would write this on your paper just as a reminder, is the probability of A times the probability of B. There are actually 4 of these different probabilities that we're going to review today. Wait.
David?
Yeah, I have to do a
So if you have a half, so say you have a 1/6 chance of rolling a 1, right, and a 1/2 chance of flipping a heads. What's the chance on 1? Yeah, so you would multiply them together. Now, the two-way tables get a little weird though, because now we're talking about like given and situations like that. So this is our normal probability of wanting both things to happen. Then we start talking about like probability of something given something.
So then we look at like it's like given they eat like.
Ooh, sorry, wait, I'm jumping ahead of myself. We want the or, right? So probability of exercise or eat fruits and vegetables. How can we figure out an or situation?
You
The probability of the exercise or. Does or make this harder or easier? Okay, yeah, what's the probability of exercise?
35.
Okay, probability of the exercise was 35%.
And then the fruit was 30.
But then you're adding the same thing twice.
So then you have to subtract both of them, right? Then you have to subtract the 25%. Because because then you're getting rid of them being added twice.
So this is the over counting or the overlap. So when we look at probability of eating fruits and vegetables out here and probability of exercising out here, we have gone across and down and we have counted this twice.
Go to the main office. Go to the main office. Thank you.
So we then have to subtract the overlap. So here's the formalization of this rule. The probability of A or B. And by the way, there's another way to write this. Hey, we're going to talk about the other way to write this before we get out of class. We had probability of A plus probability of B. How do we phrase the thing we subtracted, though? What is that? That 25% in this situation, that was the... P of A plus B is that plus that. P of A plus P of B.
Minus PA.
You can't say P of A plus B because A and B are two different situations. You can say P of A plus P of B. Sorry, what?
I'm confused because you just said a lot of it. Yeah, a lot of it.
So we said the probability of A or B happening. So the probability, let's make it easier. Probability of rolling a 1 or probability of flipping a tail. I don't care which one happens. I want one of them to happen. We're going to subtract the... What's that called?
AB?
The perfect solution.
Oh,
Brownie cake.
Nah, write it.
AB?
Write it.
Oh my gosh, I was doing brownie cake.
Crap, no!
Was it wrong?
Yeah, I'm looking at the wrong part. This is A and B. So like the and that we just talked about. The and that we just talked about. Which is this is our and here. This was the probability that they exercise and eat fruits and vegetables, right? That's the and. So that is what we are subtracting away because it is the and situation.
Wait, then what was that N supposed to be?
That's our next one we're going to talk about.
I know we talked about it before.
No, I think we did it last time, but I forgot.
We're talking about unions and
Yeah.
intersections.
Oh my gosh, I remember
Those
this.
are the lines.
Because I remember you were over teaching that one time and started talking about it, and then you were like, oh, we'll do
No,
that
we did
later.
that
So
next one.
unions and intersections. If we look at our table, how do we talk about a union versus an intersection?
Isn't an union like all of them, and then the intersection is where they intersect?
I mean,
Like the union would be like the 10%, the 25%, and the 8%, and then the intersection would be like the 25%. Right?
So the union, Eli, you keep coming and getting stuff from my class. Is this all the way,
Maybe he just wants to learn.
or this all the way?
that is
But not like we don't count this. But then the intersection is where they both happen. right? So if we remember our symbols that we use for this, the union versus the intersection is literally a U versus an N.
The N doesn't have like a little.
So union, why am I still writing in a highlighter?
It doesn't look like a highlighter.
It looks normal.
Union is literally a U, but it doesn't get a tail. That's union. Intersection
It's the opposite.
It's flipped.
looks like an N without the top little whatever.
Wait, is the union like all of them added together?
Wait, can I just reiterate?
Union is technically probability of A plus probability of B minus not union,
Oh,
intersection. Remember, union is adding them all up.
Intersection's the one that you
Wait.
not try.
There would also be two intersections.
This only happens, no, there wouldn't be one intersection. This only happens because the overcounting when we looked at the same probability twice, because that 0.25 is in A, and that 0.25 is in B. So these sums of 35 and 33 have an extra 25 involved.
Oh, wait, I think I get. Oh, I just want to reiterate. So the intersection is like.
Where they both happen at the same time.
And then the union is where.
Either of them happen.
But then subtracting.
So it could be both of them, but I just want either of them. So union is anyone who exercises. Yeah. Anyone who exercises, right? Which really in total is this 35%. We don't even need to look at these if we just grab the total. Don't add all three of these. This is the sum, right? The fruits and vegetables, anyone that fruits and vegetables, which really summed up is 33.
But if you use those two, you'd have to.
But we use this twice.
Yeah.
Now, the other option, just add this and this and this.
So you don't have to worry about.
So you don't have to worry about the overcount.
Oh.
That's your other option.
Well,
Questions at this point?
Wait, okay, how'd you get the 0.25 from multiplying? Because the 0.33 and then 0.35 are not 25 when you multiply. Like, how'd you get the 0.25 from multiplication? What'd you multiply?
That's the question. So, in the probability that we're doing now, this is what we were used to, right? If we're talking about like a coin flip or like one of those events. But now,
Got the unions and
Master Yoda
intersections.
again.
more right and more.
You really like that bright white.
Bright white.
Yeah, it's like.
P of A and B, right? That's we talked about it once. We have one way that we used to talk about it.
Which one is that? Is that union?
Which also you could just write,
Okay.
right? The vertical line for given.
Time.
Any guesses?
Oh, the probability of B given A.
Just B.
Wait, what?
I feel like if it was probably.
The probability of A and B is equal to the probability of A given B times the probability of B. And the probability of A and B is that equal to the union or intersection thing?
Well, the probability of A and B
Was that a union?
is the intersection, right? Because if we want A happening and B happening,
That's the intersection.
so the probability of A given B in this situation, well, it depends what we're choosing as A or B. Didn't we say A was like exercise? So the probability they exercise given that they eat fruits and vegetables times the probability they eat fruits and vegetables.
So are we saying that probability A intersection B is equal to probability A and B?
I mean, and it depends how you're looking at it. It all we could change what A and B are, right? We could say A is fruits and vegetables, B is exercise. I'm just trying to give you some formalized how you can like plug and chug and compute. The last one we want to talk about is probably A given B, which we've already talked about how to find that. But if you want a formalized, what you can always apply, P of A given B is P of A and B divided by P of B. So my P of A and B was 0.25, right? That probably they exercise and eat fruits and vegetables. My probability of B was what? That's probably they eat fruits and vegetables.
The probability they
33.
oh,
So that's really 25 over 33.
which is
0.75 essentially, right? So guys, think about what this is asking. What's the probability that a person exercises given that they eat fruits and vegetables? So if we go back to the table and like view this, the eats fruits and vegetables is here. And the group that exercises out of that, it's getting hard to have anything that'll show up. We're only looking at these people, the given that they eat fruits and vegetables.
25 out of 33.
Yeah, it's 25% out of the total 33. Well, that's exactly what we just found, which we've been saying, but we haven't formalized what it looks like when we write it out. So this is my numerator, right? And that given symbol tells me this is now my denominator, and that's how we get that 75%. Now, we are looking at a small population of the class, right? So if we're talking about college freshmen, I think is what this problem is talking about. 33% of them are consuming fruits and vegetables. That's good. Those are probably the people making healthier choices. And in that group, 25% of the 33, not 25% of everyone, 25% of the 33, or out of, sorry, I'm saying this wrong, do the exercises also. You could also flip side and say 8% compared to the 33 don't exercise. They just eat healthy. And if we like kind of make this our 100%, well guys, how does 33 go to 100? Times 3. Times 3, we get 75. Right? So if we make this our entire group that we're looking at, we're trying to compute what would this be as our 100% essentially. Does that make sense? Now, here's the problem. Are my events, actually no, let me ask this question. So Liang, you brought up the fact that our P of A and B on this next page, this didn't quite work out here, right? Like this was wrong in this case. That normally works, right? We've said that. We've agreed on that. We've used it. But it doesn't work here. How does rolling a die and flipping a coin differ from the health choices that you're making? By the way, preserve yourself, not your food. The longer your food lasts, the worse it is for you.
Because they're related.
Give me more. Say more about that.
Because, like, there's still a random chance of flipping a coin and, like, rolling a die or not. Like, one doesn't affect the other. But, like, you're more likely to eat healthier if you exercise, so they do affect each other.
So, if we use formalized math vocab, we would say these events
dependent.
are dependent.
Is it like drawing a
This
card back, right?
only works
If they are independent.
Yep. Only for independent events. This is only our rule if the events are independent. Eating well and exercising relate to each other. You are making healthy choices. It's not like rolling a coin and flipping a die. If I've decided I'm going to start eating healthy, the odds of me going and putting in a workout are probably higher because I care about it. But if I have said I don't work out, I don't eat healthy, I'm just eating pizzas and sitting on the couch, that's probably also related. I'm probably not going to eat a whole pizza and then go work out. Right? Like that would be a bad idea.
Your stomach be like, okay, hurl in 5.
So wait, what we're saying is anything then below this red line is related to dependent events. I would mark that on your paper, that all of this is related to dependent events. When A and B are not independent, so therefore they're dependent, that's why this works.
Wait, so all of this except for that one is dependent stuff.
Yeah, except for the, because I wrote that at the top to kind of point out, wait a minute, this doesn't work. And I'm glad that Leanne tried it and figured out it doesn't work. Now, you were asking about what?
He asked me to stop whistling because it gets annoying, and then he started whistling, and then just like stopped.
Let's keep moving, actually. So, remember this game?
Yes.
Double spin?
Yes. No, I do.
You're just like, if I say yes, maybe he'll move on.
I'd be nice, but.
So, we have double spin, right? What's your biggest chance up there?
$1.
$1. And your least chance? 100. Okay, we're all pretty darn good at this. The 100 sector is an 8th, so we don't have to make any guesses. It's an 8th. Nick is playing the game. Draw a diagram to show the sample space of every possible outcome, and I would encourage you to use an area model.
How many times is he spinning? 2.
It's
The
called
player gets to spin the spinner twice
Double.
and wins if the same amount comes up both times.
The thing is, how much do they pay to play this game?
Well, that is exactly what we're working towards. So we're working towards the point of you being able to calculate the expected outcome of an event.
And that'd be fair.
Wait, you have to draw a square diagram.
I don't know why I draw a circle. I was gonna draw the spinner, but then I realized like that's not important.
How do you do diagram for anything?
You need a lot of more than just like.
Oh snap, we have
4
another
boxes.
human. Quick, we have judge her for no reason.
Mr. Hudson.
Yeah.
Can I borrow a meter stick?
Ask Eli.
I don't know. Can you?
May I borrow a meter
Yeah, come on. They're in the corner back
When
there.
a kindergartner asks the teacher, can I use the restroom? Can you?
Yes, I can. I'm an expert in
They're not asking. You know when
I think it's just these weird ones.
It would make the most sense to either go 8 by 8 or 16 by 16 or something that's easy to work with. So if we go, I don't know, by like numerical value, 5 and 10 both get 2 8s, right? So 5 gets this much, 10 gets this much, 1, well, okay, I did not go by numerical
Wait,
value.
so
1 gets that much, and it doesn't matter if you set yours up like mine.
Wait,
It
so
really
not
does not.
whatever it is, it's not a 2 column.
Oh, okay.
Never mind.
We're doing an area model.
Yeah.
So we're going to have values across top, values across the left.
So 5, 1.
I went 5, 10, 1, 100.
Because you said you were gonna do it. And then
Sorry, I can go back and switch it if you really want.
No,
Fine. Do you want to switch it?
No, don't.
Why are you making yours with mine now?
Yeah.
No, I made my different. So yes.
Whoa, look at that. Special.
Oh, I didn't go in order, but.
It doesn't matter.
it was just.
Use your table to calculate the probability of each of these events.
I am not very big brain when it comes to.
Huge
You have graph paper. You can make a nice square.
You have graph paper too.
Sammy,
I was talking to him.
That's not a
Ah,
perfect
well.
square. I can see another line.
Oh well, it's like at least a square.
Well, yeah, that's right.
200 is 1/16. So there you go.
Are we?
Now, is spin 2 dependent on spin 1? No. So we have independent events here.
So we multiply them together.
So we
And we know
can
5
use
and 10
those
is
rules.
a fourth, right?
Well, look at him just like making sure everything is just.
Well, except my lines go a little bit far.
Wait, 5 and 10 is a fourth, right?
So I don't even really need to fill in the thing that's happening. I'm just going to fill in the probabilities. So if 5 was 1/4 and 1/4, we really get.
I think I'm not 100% sure.
How do we do the and?
160.
It's multiplication. 1/4 times 1/4 is 1/16.
I don't know if it's 1/4. I just think it is.
1/16. Oh, we could also do 4.
Oh, no.
We could do 4/64ths if we wanted.
Good.
1/16.
All the same
1/16. Yeah, all the same size boxes have the same probability, right? That's the nice thing about area model.
Why did you do that?
Did you set yours up differently and now you're
Yes,
blindly
I
following
did
me?
it in
Don't blindly
numerical.
follow me.
I did it nice in numerical order. I changed it so it'd be right on the top, but I didn't change it on the bottom, so now it's.
What's the chance of getting a 1 again? I forget.
3/8.
Great.
So 3/8 times. Well, if I go to the 1 and 1, what's 3/8 times 3/8? Well, 9. Oh, 64th. That makes sense because we have 9 squares here. There are 64 total squares out here.
Oh, so we can just count the squares.
You could, but if we want to reduce, like this would be 6/64ths, right? But that would actually reduce to at least 3/32.
Oh.
Same thing here. This is going to be the same.
I'm glad I
3/64ths. I don't know if that reduces. Yeah, it should reduce. What's 3/64ths reduced to?
I don't think 64 can be.
No, it can't. Crap. 64. So this is just 3/64ths. If this is 1/32, then I think this is 3/32.
Yeah, because
Yeah.
you wrote that before, right?
This is
And it's
making it.
6/64.
And then again 1/32.
I think I should have just
1/32.
did what you were doing.
3/64.
Yeah, but 1/64.
Ooh,
Very
1/64.
What are the odds?
Now, we're gonna overteach for a minute because you asked the question that matters.
What are the odds?
No.
Oh,
How
okay.
much does the game cost?
Oh, okay.
Right?
Remember back
So
when I asked you
these are my matching results.
Yeah.
Right? So these are my winning results.
Wait, everything else is nothing?
Everything else, womp womp, sad trombone.
Wait, how much are you paying?
$1 billion.
The question here,
That was some.
how much am I willing to pay? It's not how much does the game cost. It's before I even ask what does the game cost. I'm going to compute what I'm willing to pay because if math holds true, hold on, listen. If math holds true and we decide what we're willing to pay, we could lose 10 times in a row. But know that when the math comes back around to true, like when the law of large numbers applies, I will eventually come out on the positive side of money if I first calculate the expected value. So what is the chance?
Really?
What is the chance I win $1?
9/64.
So we would do 1 times 9/64.
Oh, 964. Right.
What's the chance I win $5?
$5.
1/16.
1/16. What's the chance I win $10?
1/16. That's because I
Oh,
did
it's the
1/16.
And the chance I win $100?
Not 164. Fool, you ain't getting that.
Unless you're very lucky.
Unless if you're very lucky, yes, yes.
Or you play long enough.
Yeah, it's sit there.
Oh
the
yeah,
rest
just
of
keep
your life.
going like over and over and over.
I mean, yeah, you would have to have a job if you just kept playing this game.
Wait a minute, something's not right here.
Just make
you should be finding these in decimals and adding them up, or whatever you want to do. But what's this add up to?
In decimal or fraction?
Yeah, in decimal form.
Yeah, I got a calculator. Woo, yay! Don't you have a calculator?
I don't. Oh my. Did you just knock it to the ground?
I said that my dream.
Might take a while because a lot of numbers do.
Okay, maybe I'll help.
Oh no.
I don't know what to do. I'll do the last one.
I already did it.
Oh.
What has happened?
What is the outcome that occurs in the orange space?
Get doo-doo on.
I don't know.
Thanks for the money.
We just lose, right?
Yeah.
So 0, right? So if we're truly computing expected outcome, which I don't have to teach you yet, but I am because you asked, 0 times all of these probabilities put together, that would still be 0. And 0 times all of these probabilities put together would still be 0. So that's not going to impact what we're doing over here. Did anyone add these? Can we get somebody doing it? If we had them all in 64ths, it would have been nice, but I have 109 64ths, 15 16ths. It's over 1. I guarantee it's over 1.
Well, because 164th is over 1 already.
Okay, I have it.
What is it?
Press the enter. 2.078125.
So that's how much we're willing
Yeah,
to
I'll
pay.
make sure.
2.078?
Yeah.
That's how much we're willing to pay.
No.
Dang.
That,
Where?
sorry, I should put a dollar sign. That is the
That's
expected.
not what I got.
Oh no.
Well, I didn't. Did you round?
No.
Well, what'd you get, Sammy?
I got 2.640.
Okay. So either way, it's approximately 2. We got to check some math, but we have approximately 2.
I can do this.
2 something, right? If this game cost $1,
Oh my.
the expected outcome of every time you play is approximately 2.
So then let's pay 50.
So, guys, it should be 109 64ths.
You added a 0. So you did it wrong.
Oh man.
Ha!
I added.
Ooh, what'd you get then, Sammy?
2.640625. So
You did
roughly
more money. That's good.
2.64.
Hey, here, and we'll get out of here because we're over time. Sorry, I normally release you early. We're over time. This is the expected outcome. That's a positive value. So here's the trick. You walk up to this game, and you're like, I could win $5, I could win $10, I could win $100, and I have a better probability of winning a large sum. So they're like, all right, it only costs $3 to play. And you're like, $3 to play? I could win 5, I could win 10, I could win 100. I'll play for $3. But the expected outcome is 264. So the expected thing that will happen is every time you play, quote unquote, you lose 36 cents.
Oh my
Oh,
goodness.
that number is what you
Master the
So if the game was $2, you're at an advantage. If the game was $5, walk away from that. That's where we use expected outcome. Hey, hold up, one last thing. 7th grade has a modified schedule tomorrow. They have science fair. We still have class. Okay, 8th grade is still operating as normal. Goodbye. Lee Yang made a mistake. I don't know how I feel about that.